Have it since Badara and also Mas Agus is already here. I think we can start uh, the discussion.
Uh, Sorry, Bu Oni, you can hear my voice?
Yes, it's very clear.
Oh, okay. Thank you, Oni. Iya. Oke, ya. Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, good evening, and good night, everyone. Welcome to Indonesia Regional Focus Group Meeting, VLab Center of Excellence, December 2025. Today, or the last RFG in this year, the Honorable all speakers, Mr. Agus Salim Nur, Mr. Boni Panjaitan, and Mrs. Adidadar Fahada, also the Honorable all participants of this meeting. I'm Hafid, and also I will be the moderator of meeting today. I'm very pleased to see you here and welcome to this meeting. Before we begin, I would like to inform you all, we apologize as Mr. Boni is unable to present the material today because several important matters, but we have two presenters. Our presenters for today are from the Directorate of Public Meteorology, and they will present about the 2025 annual satellite-based weather summary. Before the presentations begin, let me inform you all. If you have any questions, please typing in the chat box during the presentation or raise your hand after the presentations. And also don't forget to all to fill the presents while the committee shares the link in the chat box. Now we start to first presentations by Mr. Agus Salim Nur from Directorate of Public Meteorology. Mr. Salim working as an expert on the satellite meteorology, and he will present about a summary of tropical cyclones within the TCWC Jakarta monitoring area during this year 2025. Mr. Salim, you have a maximum 20 minutes for the presentations, and please, time is yours.
Okay, thank you, Mr. Hafid. I will share my presentation. Okay, good morning, all participants. I greatly appreciate the opportunity to participate in this activity, even though we are currently in the holiday period approaching the new year. I will provide a brief summary of tropical cyclones within the TCWC Jakarta in the monitoring area. Okay, on this occasion, I will attempt to present several key points related to the summary of tropical cyclones in 2025, namely the TCWC Jakarta area of responsibility, and then statistic of tropical cyclone occurrence in the northern and also in the southern region, tropical cyclones that developed in 2025, and overview of their spatial distribution, and then a brief discussion of tropical cyclone scenario that will be highlighted in 2025. In addition of its responsibility under the WMO mandate, TCWC Jakarta also has a design monitoring area to provide early warning for extreme weather that may be indirectly caused by tropical cyclone developing further from the Indonesian region. Such system can at times trigger the development of extensive convective cloud system due to the wind turning or wind shear area of the wind declaration and also the convergence. And our monitoring area covers 20 in north and 220 in south and also 90 to 141 east. And this is and the following present the monthly number of tropical cyclone occurrences and the corresponding monthly average in the southern region. The highest number of cyclones and the highest monthly average occur during the rainy season for most part of Indonesia, namely in January and February. Nevertheless, southern Indonesia should already be on alert from November through April, as several tropical cyclones within the TCWC Jakarta area of responsibility have developed in November or April, and the maximum average occurrence in is 2 tropical cyclones within a single month. And then in the northern region, the months with the highest number of tropical cyclone area from July to November, the highest monthly average occurs in September with an average of 4 tropical cyclones in a single month. And then in 2025, we have 10 tropical cyclones developed between January and December in 2025. They are January, we have 3 tropical cyclone, and February we have 2, and March we have 2, April we have 1, and December we have 2. And mostly in south of Indonesia, they are mostly under the average, monthly average, but we have January and also December actually, because this early morning we have another TC developed, the TC Haaii. So January and December we have 3 tropical cyclone, which is above the monthly average, which is only 2. And then in the northern of Indonesia, we have 13 tropical cyclone that develop between January until November. We have November we have 3 tropical cyclone, and then September we have also 3 tropical cyclone, which is the highest number of tropical cyclone that develop in the northern part. And there is a highlight also in the Malacca Strait, which is developed in November, we have TC Senyar, which is developed in the rare region that we maybe have not history that there is a tropical cyclone that developed in the Malacca Strait. The following illustrate the spatial distribution of tropical cyclones in southern Indonesia, with the highest density over the southern Indian Ocean, south of Sumba Island is Nusa Tenggara and near Australian waters. From this spatial distribution, it is clear that Indonesia is not entirely safe from tropical cyclone impacts, even though most of its territory lies south of 10 degrees latitude. But from here, we can see that there is tropical cyclone Chloe in 1995, tropical cyclone Errol in 2002, Indigo in 2003, Kirili 2009, and also Seroja in 2021. That is developed at latitudes below 10 degrees and within the Indonesian archipelago. Although such events do not occur every year, but enhanced preparedness to support disaster risk reduction objective is clearly essential for Indonesia. For 2025, tropical cyclone Senyar may be considered a key highlight, given its unusual development over a narrow body of water and at approximately 5 degrees latitude, even moving at latitudes below 5 degrees. And then tropical cyclone Senyar caused very significant impacts, particularly across three provinces on the island of Sumatra, which is Aceh, Sumatra Utara, and then Sumatra Barat. The loss of life, material damage, and also environmental destruction resulting from the tropical cyclone Senyar represent the most severe event since the establishment of TCWC Jakarta. So I think TC Senyar is more destructive than TC Seroja, which is in 2021 in Nusa Tenggara Timur. And tropical cyclone Senyar developed in the Malacca Strait east of Aceh, and then move inland along the Aceh coastline before turning southeastward and re-entering the Malacca Strait. And the lifetime of tropical cyclone Senyar was less than 24 hours. And notably, this system formed within the Malacca Strait, where based on our review of historical from data in IBTREX, no tropical cyclone has previously been recorded developing there. The associated convection was highly extensive and resulting in heavy to extreme rainfall across three provinces, which is Aceh, Sumatra Utara, and Sumatra Barat. And this is TC Haaii, tropical cyclone Senyar may be comparable to the tropical cyclone Haaii, which is developed near the equator. I think TC Haaii is more close to the equator because it is under 3 degrees. However, Haaii from over a relative broader oceanic area because it's developed in the South China Sea, east of Singapore. It's different with TC Senyar, which is very narrow water, which is Malacca Strait, and we don't have history as long as I see from the dataset from the IBTREX. So this is more close to the equator, but TC Senyar is more unique than TC Haaii, I guess. And this is the development of satellite image from 25 November. So we can see that the development of deep convection is very massive from 25 in 12 UTC, and then it developed to become a tropical cyclone in 26 November in 00 UTC, which is named by RSMC New Delhi because this area is under RSMC New Delhi. Even this area is in Aceh or Indonesian area, but the responsibility to name the system is by RSMC New Delhi. The consistency of dense overcast and also deep convection also persists more than 12 hours. That's why the system is reach the TC intensity in 26 November 00 UTC. And this is another satellite data from Ramsira. This is the visible canal and also infrared. You can see that there is a development in 26. We can see the development of overshoot top from the visible canal. And the following slide is about radar imagery, shows that the movement of tropical cyclone Senyar during its formative stage, with the circulation center clearly identifiable. On the left is the rainfall distribution map for the Aceh region on 25 November in 2025, indicating that most area of Aceh experience extreme rainfall, which is more than 150 millimeter per day, and particularly in the southern and eastern coastal region. Observation recorded the highest daily rainfall of 411 millimeter per day along the east coast of Aceh. And this is the data of the observed rainfall in the Aceh region. And this is another data in 26 November, which is extreme rainfall that happened in the Sumatera Utara and also Sumatera Barat. And this is for the closing, learning from the case of tropical cyclone Senyar, which developed at very low latitude below 5 degrees, and in a region where tropical cyclone formation had not previously been observed. This should serve as an essential reminder for Indonesia regarding the potential for tropical cyclone development within its internal waters, such as the Java Sea or Banda Sea. While the probability may be low, but the high population density in Java and the presence of numerous small islands around the Banda Sea mean that even a small system could result in significant impacts due to very high exposure. And Indonesia must therefore take prompt steps to raise awareness of tropical cyclones. Residents in urban areas maybe have relative good access to early warning information related to tropical cyclones, but however, communities in remote areas still require substantial support. And based on post-event tropical cyclone public survey that we are conducted in Nusa Tenggara Timur and Maluku in 2022 and also in 2023, many people remain unfamiliar with tropical cyclones and their impacts. So I think this is addressing this gap remains a shared challenge for us. I think that's all from me. Thank you, Mas Hafid.
Okay. Yeah. Thank you, Mr. Salim, for the great presentations. Now we move to the next presenters, the last presenters for the RFC today, Mrs. Dara from Directorate of Public Meteorology. So she will present about the utilization of satellite application in coloring Himawari single band image, enhanced infrared and water vapor product. Please, Mrs. Dara, time is yours.
Okay, thank you, Mr. Hafid.
I'll try to share my screen first. Hello everyone, and thanks for joining the meeting. For those who I haven't met yet, I'm Adinda from Weather Satellite Imagery Management Team. I'm here to walk you through the utilization of satellite application in Himawari single band color enhancement. By the end of this session, you will have a view about how satellite works in single band color enhancement and what needs to improve further. All right, let's begin by the next slide. Okay, about the operational routine product that BNKG Indonesia produce. One of the product is namely enhanced infrared for Indonesia and provincial areas. The available products can be accessible for public and internally BNKG user. The public accessible product is the real-time imagery every 10 minutes for Indonesia and provincial areas. And then for the internal BNKG users, the data, the raw data every 10 minutes for Indonesian region, which is can be derived or zoom in into specific area. And then the processing of these products are using the Python programming generally, and also with a satellite application. And the highlight of this presentation is about the satellite color enhancement, which is the product that we produced daily, could be enhanced by the application from GMA, namely Satellite, which offers more flexible user interaction for qualitative analysis. This is the appearance of enhanced infrared product that we produce daily every 10 minutes, which this image describes cloud top temperature derived from observations of long-wave electromagnetic radiation at 10.4 micrometer. The temperature values are classified into several colors. The black to blue indicates clear sky. Brighter colors correspond to higher and colder cloud tops. The information helps to identify significant cloud formations and the existence of cumulonimbus cells. Jump into the satellite method. Firstly, we need to install the application from the GMA website, and then download the app along with the instructions. And then we need to prepare the raw data level 1 of Himawari. For this study case, we take example of band 13, 10.4 micrometer. And then we move to the processing raw data, which is setting the emphasis or the color graph. And then once the app is installed, we need to double click this icon, GMSLPD 64, the application, and then we will see the pop-up, the big pop-up window named Satellite like this. And then we can start to register the file by hit Ctrl F on the keyboard. After the raw data is registered into the application, we will see the original raw data in black and white images right in front of us. And then you can explore the right bottom panel of the window, which consists of gray measure, ops, info, etc. And then we need to activate the radio button gray. Excuse me for a second. And then we move to the next step is after we activate the radio button gray, another option will appear below, and then we need to click color. After that, another small pop-up window will show, which is namely setting the emphasis. In this window, we have so many radio buttons, and we only need to click the XT0, left click, I mean, and then after click the XT0, this window, the window of editing the emphasis will appear. After that, this graph, the editing the emphasis, need to be modified. When you need to modify this graph into this one, into this new color graph. How to modify the color graph? You need to activate one of the color component up here. Firstly, at the red component, we need to set the color value into this graph, and then move to the green component color, and make the color component like this graph, and then move to the blue component color along with this graph. And after that, the result will appear like this. There are still some significant differences with the original or the Python producing product in enhanced infrared, but this product is almost seemingly appear almost the same one. And then for the summary of this satellite application, satellite have strengths which is quite good in interactive and visually qualitative analysis for the users who doesn't have any experience in Python programming. And the limitation, the custom color schemes cannot be saved automatically so far, and requiring manual configuration at the time when we need to analyze the raw data at the certain time. And then the suggested improvements, there needs to be an auto save function for color settings in the application, and made a create user-friendly color management interface within the satellite, so the development and the distribute standardized color profiles for specific weather phenomena can be seen quite easily. Okay, that's all from me. Thank you very much for the opportunity. I will give it back to the moderator, Mr. Kapit. Thank you.
Okay, thank you, Ms. Dara, for the presentations. All right, and now we move to the questions. If you have any questions, please raise your hands, or you can typing in the chat box. And also don't forget, everyone, to fill the presence link for the RFV today in the chat box. Any questions? Sorry, from Bu Ani.
Okay. Okay, thank you, Hamid. First of all, I would like to thank all the speakers, Mr. Agus and also Madara, for sharing your experience or your knowledge in utilizing the satellite meteorology, especially for analyzing the weather, extreme or weather events in 2025. I just would like, I have the curiosity to know from inside or during specific or special analysis conducted on utilizing the satellite meteorology in 2025, maybe we can discuss in here. Thank you.
Okay, thank you, Bu Ani. So any questions?
There is question from Bu Ani that I already answered in the chat box.
Yeah, okay. Thank you, Pak Salam. Okay. Any questions from participants?
I see. Oh, thank you, Pak Agus. I saw your answer in the chat box. Yeah, so yeah, for the Ecuador region, it must be very challenging.
Yes.
Analyzing the weather events. So how is, I mean, what is the, is there any suggestion or trick, tips and trick when you are doing the analysis using the satellite meteorology for the tropical region?
Yeah, okay, thank you, Bu Ani. Yeah, because some part of the step to doing analysis and also forecasting tropical cyclone is like subjective result. Even we have also automatic result also in another reference, but we also have doing some manual action to have another opinion result for the intensity and also the forecast. So that is the point that why we almost often to find difficulties because of we are in near the equator. Mostly the system is only tropical low and sometimes it's tropical depression, but not yet as a tropical cyclone. There is a step that we have to do cyclogenesis and also the forecast technique, which is it's also manual with using satellite too. And another problem maybe because we have very dynamic personnel rotation. So we have to routine refreshment training every year. But you know, tropical cyclone in Indonesia is not always every year, or maybe not always every month. So we have to always doing refreshment training every year, or maybe every several months. That's the point. Maybe different like JMA or maybe the Philippines, even though they don't have any responsibility area, but they have so many experience from the tropical cyclone that's crossed along the Philippines area. That's my answer, Bu Ani.
Thank you, Pak Agus. How about that?
Thank you, Pak Agus, for answer. Thank you, Bu Ani. Any questions from participants? I mean, from other participants or sorry. And also from the college. Okay. From Mr. Ulil Hidayat Kalimarau to Miss Dara, I see that you using satellite to colorizing or enhance the image of single bands, especially IR band, I assume. Can you explain how single color enhancement in satellite is used operationally to monitor convective clouds? Thank you. So please, Ms. Dara, to answer.
Okay, thank you for the question, Mr. Ulil. Operationally, for the using satellite application is not suggested, I think, because for operational product requires the rapid time observation and the availability of the images in short time. But this color enhancement using satellite application is required for the analysis or the post event. So if you need to analyze severe weather without using any Python programming, you can use this satellite application to analyze this. Okay, but for the operational use, which is requires short time display, short time availability images, satellite application is not recommended to be used. That's what I think. Thank you.
Thank you, Udara, for the answer. Any other question from participants? Or I think it's enough. Any question? Okay. I think it's enough from the RFG today. So before we close the meeting today, Bu Ani, do you have any remarks for RFG today? I mean, the last RFG in this year.
Okay, thank you, Hafid. So I just would like to thank you all once again for joining this last RFG event, Regional Focus Group discussion of Indonesian Virtual Laboratory Center of Excellence on Education and Training in Satellite Meteorology in 2025. Not the last ever, but this is the last for the 2025. So we do really appreciate your involvement in our regional focus group discussions. We really hope that next year, in the regional focus group discussion next year, we also would like to hear from some participants here to provide your knowledge, for example, to share your knowledge to our community, our regional regional focus group discussion community. So happy New Year, everyone. Hope to see you again in our regional focus group discussions next year, and also in another training events next year and ahead. So I think that's all. Hafid, I return this back to you.
Okay, thank you, Bu Ani, for the remarks. Okay, finally, now we have reached the end of this meeting. So I'd like to say thank you to all presenters for the great presentations and to the participants for their active participations. Thank you for your attentions for the RFC the last year, and have a great day. See you in the next RFG meeting and the next year. Bye-bye.
Bye. Thank you, Bu Ani. Thank you, Mas Hafid.
Thank you,
Pak
Pak
Agus. Thank you,
Salim. Thank you,
Dada.
Udara.
Thank you,
Thank you, Bu
everyone.
Ani.
Makasih, Pak
Thank
Fit.
you.
Thank you so much. Happy New Year!